different types of NMR under proton NMR also, yeah, but we have two different types. Okay, one is going to be low resolution, okay, or if you take it in a layman's term, okay, it's like a not so HD, yeah, so SD, yeah, it's not going to be high resolution. Okay, we have low resolution and high resolution. What is going to be low resolution and high resolution? The difference, if you look at YouTube video, yeah, so they say that, okay, high definition means, okay, you can see everything clearly. Low resolution is going to be whatever you want to see, you see, but you are not going to be able to see all the details. That's the difference. Okay, whatever things that we have learned until now is called low resolution. Okay, so we are able to see, like, for example, if you look at ethanol, you can see all these 1 peak, okay, 2 peak, and then 3 peak is low resolution, like what we have learned. Okay, no problem. Okay, low resolution was what we have learned until now. So the idea behind low resolution is you are going to have single peak for each non-equivalent hydrogen atom. Okay, ethanol has 3 peaks because 3 different environment. Heights of the peak may vary. Yeah, so the area tells us the number of hydrogen atoms responsible for particular chemical shift, okay, and so on. Basically, they're just talking about this. Yeah, so the idea is low resolution NMR is the what we have learned until now. Yeah, so they continued further. They tell that, okay, all these peak, okay, this particular peak corresponds to what? Okay, they say this is going to be around 5.4. Okay, this 5.4, if I look at 5.4, it's going to be ROH. You can see ROH. So it means I know, I can predict this is going to be for this hydrogen. Okay, and then because it's 1, so it's confirmed that 1. Okay, and then if it is 2 hydrogen, okay, you see most likely this one. Okay, but how do we double confirm? Okay, we can double confirm by looking at 2. So you just look at here 2. Okay, I think most likely this one will be the answer. But look at the data. So if you look at the data, this is going to be 3.3 to 4.3. So which is confirmed. Okay, we have identified this part. Remember in the beginning itself, I told you it's like solving a puzzle, yeah, jigsaw puzzle. So you see, first you solve this puzzle. Okay, you solve this particular puzzle. Second, you manage to find this puzzle piece. Okay. Third, okay, you are going to look into these 3 hydrogen, most likely this one. Let's see whether it's confirmed or not. So if you look at here, okay, this is going to be at 1.2. 1.2, if you look over here, okay, it can be here or here. So, but here it's going to be, we are looking for 3 hydrogen. So CH3. So it means it must be CH3. So CH3. So if you look at overall, okay, the picture now is complete. So I know that this is going to be ethanol. This is how you predict. Okay, you put all the pieces together. Okay, so that is what is the use of an MR. Okay, but I will move forward. Yeah. So here, okay, this is going to be the high resolution or the HD. Okay, high definition version. Okay, where they can give you more information. Okay, you can see more detail. What are the detail? You see, generally chemical shifts are given in ranges. Yeah, even for low resolution and so on, you can see all of them are going to be given in form of range. Okay, so because of this range, sometimes the ranges overlap. Like for example, here you look at this. It can be 2.0 to 2.9, 2.3 to 2.7. What if I have the value 2.5? Okay, my 2.5 will be between here and here. So I don't know whether it's this or here. Okay, I will get confused. Okay, so what HD version will do, okay, the high resolution version will do, they will give you more information so that you can actually perform some sort of analysis where you can predict between these two. Yeah, they will actually give you more information. So what kind of more information? This one I would like to, I normally like to refer it like this. Okay, imagine you like to hear music very loud. Okay, and you decided to at night 10 o'clock you suddenly throw a party and then you put your music too loud. okay, depending on the neighbor that you have, okay, let's say you are living in a corner house, okay, of course, the person who is going to complain is going to be the house next to you, okay, they will come and complain, hey, come on, yeah, it's time for my kid to sleep, okay, switch it off or something like that, they will come and complain. Okay, now if you are staying, okay, in a place that is going to be in the middle house, so it means there will be two neighbors over here, and sometimes also you might have another neighbor staying in front of you also might get disturbed, so you are going to have three people disturbing you, okay, three people disturbing you. So in this case, okay, what I'm trying to say is the number of people who's going to disturb you depends on how many neighbors you have. Okay, how many neighbors you have. The same thing, okay, in NMR, okay, if you have a pig, okay, if you have a pig, this pig is going to be disturbed by your neighbors. Okay, it's going to be disturbed by your neighbors. And normally this one I like to put it is if you in Indonesia, okay, I think or even in Singapore or Malaysia, if you want to disturb people, people will just go and fight. Okay, so what they do, they go and okay, call the RT, yeah, or call the police, yeah. So let's say if you have three neighbors, okay, what will happen? These three neighbors will come to you and also bring the one representative. Okay, the RT or the RT, or they bring the police. Okay, so it means that this is going to be the number of disturbance is going to be followed by n plus 1. Okay, how many neighbors that you have, and you bring another one. That another one can be RT, or that another one can be the police. Okay, you can remember in that way. So now, okay, if you look at it, okay, some molecules, okay, they have heavy shielding of hydrogen nuclei by lots of electrons in surrounding atoms. Peaks are shifted beyond their usual range. Okay, so high resolution NMR is useful for those cases and give more info to interpret. It means that, okay, because of these neighbors, okay, the peak is going to be shifted a little bit. Okay, they are going to be shifted a bit, which they are going to be called as splitting. Okay, the peak is going to be splitted into a few parts. Okay, the peak appear as one signal in low NMR are now made of cluster of grouped peaks. Okay, so now because they are breaking apart, they are going to be grouped peaks. Okay, this is because of the neighbors. Yeah, this is because the magnetic fields generated by spinning nuclei interfere slightly with the neighboring nuclei, which is what we call as spin-spin coupling. Okay, so it means next time when you actually open up or you have a lot of noise in your house, if people complain, you remember spin coupling. This is spin coupling. Okay, where they are going to get disturbed. Okay, they are going to bring a police towards you, yeah, or they are going to bring someone to us, yeah. So this is what we call spin coupling. The splitting, okay, depends on the number of hydrogen atoms on the adjacent carbon atoms. Okay, so if you look at an example, okay, if I have, let's say, for example, like this, okay, if I am going to look at high resolution version, okay, for this hydrogen. Okay, for this hydrogen, the neighbor, okay, is this one. Okay, this is going to be the neighbor. This is going to be the neighbor. So how many neighboring hydrogen that you have? You have two. Okay, because you have neighboring two, remember you need to bring another one more, n plus 1. Okay, so how many n plus 1? So it's supposed to be 2 plus 1, you get 3. The splitting pattern is called triplet, okay, which is going to be 3. Okay, so this is going to be triplet. So how will it appear? It will appear like this. See, 3. Okay, it's going to be one main, and then you have 1 and 1. Okay, splitting. Okay, I'll erase because it's already ugly, but you see here, like this. Okay, they are total. Okay, you have 1, 2, 3. Okay, don't follow these 3. Yeah, this is different. Okay, these 3 peak splitting is going to tell about there are 2 neighbors. Okay, who's complaining? Yeah, there are 2 hydrogen. Okay, beside the hydrogen, that we are analyzing. So that's the meaning. So if you look at, if I erase this part, cannot erase. If I look at this hydrogen now, if I look at this hydrogen now, the neighbor, is going to be this neighbor. This is going to be the neighbors. This is not the neighbor. This one is like very far away. He's not bothered. So the 3 hydrogen, they will bring another one more. The police. So you are going to have 4. This is going to be called quartet. Quartet. So how? CH2, the 2H, you see? 4. Splitting. You can see. And then the last one is special. Anything that is attached to O, and later we learn nitrogen, they are not going to have any neighbor. You see, the neighbor is supposed to be normally carbon, but here they are attached to oxygen. Oxygen don't have any hydrogen. So don't need to go towards this carbon. No need. No need like just now. Like just now we say attached to carbon, then you go to the next carbon. For this one, the one that is attached to oxygen, no need. Because the splitting, they are going to be special because the splitting will not happen. They are going to have continuous replacement of the hydrogen. From where? They are going to replace from other molecules of ethanol, and they are going to replace with water. So because there is constant replacement, there is no splitting. It's like the moment the neighbor wants to disturb you, you turn off the volume. You say, where God? Then the neighbor get disturbed again, then you turn off the volume. When they start to complain. So it means that you will not get any splitting. Nobody will complain. So this is about hydrogen that is attached to O. Not only hydrogen attached to O, the hydrogen attached to nitrogen also. They are not going to give you any kind of splitting. This is special. So now, if I look at the splitting, you see, generally the splitting, what does this mean? It means that most likely, this is most likely the neighbor, there is they are going to be hydrogen attached to O, or the hydrogen attached to N. This is the most likely. Later I'll come back to that question. Someone chat. But now if you have splitting which is going to be 2 like this, this means that the hydrogen is attached to the carbon, that may attach to another carbon that has 1 hydrogen. So this one may be something else, I don't know. So 1 hydrogen. So rather than drawing, I'll just tell you, 1 hydrogen neighboring. And here you are going to have 3. It means your neighbor has 2 hydrogen. Neighbor. Neighbor has 1 hydrogen. So neighbor has 3 hydrogen. So now I'll try to answer the question. For the second hydrogen, is there 4 hydrogen? So 4 neighbors. For second hydrogen, which is second hydrogen? Oh, you mean, Frederick, do you mean this one? This one, because they are following the same environment, the neighbor is going to be only 3. Don't include this one. This is the same environment. You don't complain yourself, right? When you are the one making the noise, you don't complain on you. The same. The same concept. When you have this hydrogen, how many neighboring? You don't count 1, 2, 3, 4. You count neighboring from here. Only 2. So that is how it works. So you look at the carbon adjacent. Carbon adjacent. Only for special case for OH and NH. Now, let's look at example. Now, in this example, they say that ester is used as a solvent in glue. Okay, so everyone should know, yeah, ester is going to be R1, C double bond O, O, R2. The thing that I don't have details over here is, I don't know what is R1 and I don't know what is R2. I am going to use this NMR reading, okay, to find out, okay. But just before that, Wilson, is this low resolution or high resolution?
Is it high, sir?
Yes. Why?
There's like the triplet.
The moment you see splitting, okay, the moment you see splitting, splitting doesn't exist for everything, but the moment you see splitting, okay, which is you can see here, okay, and then here, the moment you see splitting, this is a high resolution, okay, this is high resolution. Now, I can determine this molecule just by not even looking at, okay, certain values that is provided in data booklet. You see how it can be done, yeah? So here you see, I have, okay, in total, I have 3 peaks. If I have 3 peaks, it means that I have 3 hydrogen environment, okay? That is the first thing that I need to know. I have 3 hydrogen environment. Out of these 3 hydrogen environment, yeah, so it means that if I have, okay, of course the hydrogen environment don't simply just come with a H over here, okay, possible, okay, possible 1 H, but there is no 1 H here, okay. I hope you can understand, okay. It cannot be H over here, cannot, okay. It cannot be 1 H over here. Why? Because there's 2 H, 3 H, 3 H. There is no 1 H. Okay, so definitely cannot be 1 H over there. So I know that they must have carbon. So it means that I must have carbon. Okay, so I have O, then must have carbon, but I do not know the carbon can continue or not. Okay, is there going to be another carbon or so on? Okay, we don't know. Okay, but looking at the data now, okay, look at here, yeah, there is one part that they mentioned that they are going to have, okay, 3 hydrogen, okay, but there is no splitting. So it means there is no neighbor, okay, 3 hydrogen, but there is no neighbor. So in this case, maybe I have two possibility. Maybe I have CH3 here, 3 hydrogen. Beside, there is no hydrogen, okay, or I can have another possibility, CH3 here, C double bond O, O, then C, I don't know yet. This is another possibility, okay? So there are 2 possibilities now, yeah, based on here. Now, if I look at other examples, okay, they say that for 3 hydrogen, okay, there is 3 hydrogen. If I have, let's say, for example, CH3, it means that there is another 2 environment. In order to have another 2 environment, you must have another carbon. If not, you are not going to have enough environment. Okay, you must have another carbon there. Okay, if I don't have another carbon and I put everything as H and H, there is only one total. You are going to have 2 environments only. I need 3 environments. So it means that I must put another carbon there. I must put another carbon here. Okay, to make it, I have 3 environments. Okay, now if I look at that, okay, I know that this one done. I know that one contains 3 hydrogen, another one contains 2 hydrogen. It means, okay, 3 hydrogen, 2 hydrogen, 2 hydrogen, 3 hydrogen. It makes sense, right? I put like this. Okay. Now, if I compare, okay, now I think most likely this might be my molecule. Okay, just check. Thompson, do you think both of these molecules, are they the same or different?
The same.
They are the same. So you see, there is no need for you to look at the chemical shift also. Okay, normally we will have two different molecules, then we compare. Yeah, but in this case, they are the same. So I know now, okay, roughly 90% it might be correct. Okay, but if you ask me, I know it's 100% correct. Yeah, but okay, if you want to find out more, you can find out more. Yeah, so you see, okay, look at the value. This one near to 4. Okay, if you look at the data booklet, near to 4, okay, that is going to be two hydrogen. It means we are talking about this one. Okay, so you can see they are split into 3. Yeah, so beside there's 3, correct? And this one, you can see 4.1. We are looking for 2 hydrogen. 2 hydrogen, you don't look here. Okay, you look here. And you see CH2, 1R and O. CH2, 1R and O. Correct. Okay. And then now look at here. 3 hydrogen and around 1.9. Okay, look for 3 hydrogen. CH2. Okay, we are looking at CH3. And this one. CH3CO. CH3CO. It belongs to that. Okay, and you know that there is no hydrogen. Okay, therefore, okay, there is single peak. Okay, confirm. Then 1.3, which is this one. Okay, 1.3, 3 hydrogen. 1.3, 3 hydrogen. This one. Okay, bonded to R. Okay, so you see bonded to R. This one bonded to R. This entire thing is R. Okay, this is also correct. Okay, this is, you confirm, okay, that this is the molecule. Okay, how do I name this molecule? I hope you still remember how to name molecules, ester especially. Okay, Frederick, you want to try how to name? First, I'll guide you together. Yeah, first you break here. Okay, you break it over there. And then you put, this is OH, which is the carboxylic acid group. Okay, and this is going to be alcohol. Okay, so which one comes first? Okay, do remember carboxylic acid. So Frederick, this one, if it is carboxylic acid, what is the name?
Ethanoic acid.
Okay, so you name it as ethanoate. Okay, this is going to be ethanol. So you change it into ethyl. So what comes first? Okay, alcohol followed by carboxylic acid. If you are not sure, follow alphabetical order. A, then followed by C. Yeah, so the name is ethyl ethanoate. Okay, I hope you remember this. Yeah. So by looking at the rules and so on, you can come to that. But you see, you found out this is going to be the ester, ethyl ethanoate. Okay. Now, maybe some of you still confused. Let's actually try more questions. Now, they are telling that, okay, you are given 2 different drugs, okay, unknown drugs, and you need to identify, okay, which one, okay, is the unknown drug, okay, by using the NMR, okay, the data. And if you look over here, so let's actually see, for even, is this HD or not HD, high resolution or low resolution?
Is it low?
No, high, okay. You see, even, again, can you see splitting here?
Yeah, sorry, I didn't see that. Sorry.
The moment, yeah, the moment you see splitting, okay, the moment you see the splitting, automatically it's going to be high resolution. Yeah, so I think here, okay, there is a mistake. Yeah, it's supposed to be only 1 without any splitting. Yeah, but later we'll look into that. Now, if you look at this structure, okay, aspirin and paracetamol, and I want to find out, okay, which one, okay, how many hydrogen environment. Yeah, let's actually look at the hydrogen environment first. Okay, now this is going to be one hydrogen environment. Okay, this is going to be another one hydrogen environment. Now, the moment you look at this kind of structure, okay, remember I told you to try to form a symmetrical line. Okay, if I try to follow a symmetrical line, it's not possible. Yeah, because if I want to, I cannot draw a symmetrical line like this. Okay, so what I need to do, okay, if I want to draw, yeah, so definitely I need to draw maybe something like this, or I need to draw a symmetrical line, something like this. Okay, and what by any means, yeah, by any means you draw. Yeah, so what I will get is, if I draw that, I will identify that this is going to be one environment. Okay, now I cannot conclude that, okay, these two the same. Why, Giuliano? Why I cannot conclude that they are not the same? Why I cannot say that they are the same, Giuliano?
Does it connect to the benzene ring?
You see, this hydrogen, the neighbor, is connected to carboxylic acid. This hydrogen, do they have any neighbor connected to carboxylic acid? No. Okay, in this case, this is going to be a different environment. This is going to be a different environment. They are not the same. Okay, they are not the same. So how about here? This is going to be another different environment. Okay, you see they are going to be, the neighbor is this and this. Okay, this is different neighbor. So this is going to be another different environment. So in total, how many different environment I have? Okay, I have 1, 2, 3, 4, 5, 6. Let's see whether I have split 6 peak over here. 1, 2, 3, 4, 5. Automatically, I already have doubts. Cannot be this. Okay, but you still need to analyze further. Yeah, cannot. Yeah, cannot be that. Okay, but let's actually look at this. This is going to be the same environment. So 1. This is going to be another environment. Okay, and then this is another environment. So let me use different pen. So what you can do, okay, you can actually put like this. Okay, now if you fold it, okay, if you fold, okay, it is much more easier to see. Okay, I will see that this environment is the same as this environment. I hope you can really see this. Okay, if you fold this and this, they are folded nicely. Okay, so you no need to worry about this, no need to worry about this. Okay, but this hydrogen and this hydrogen, they are the same. They share the same neighbors. Okay, and then if I look at this particular hydrogen, this and this are the same. Okay, so how many different environment that I have? Okay, if I count 1, 2, the orange, 3, 4, 5. How many peaks I have? 1, 2, 3, 4, 5. Most likely, yeah, paracetamol. Yeah, but we cannot say for sure. Yeah, maybe still, yeah, 60%. Yeah, 60%. So let's actually see further. Okay, now I narrow down to paracetamol. I need to find out whether is it true or not. Yeah, Okay, for hydrogen, you see for hydrogen attached to benzene. Okay, if you look at the data, hydrogen attached to benzene, see hydrogen attached to benzene, the value is 6.5 to 8. Okay, 6.5 to 8. So now you look at here, 6.5 to 8. Do they have within the same range? Yes. Why? Okay, because I have two hydrogen environment here, which is similar as these two hydrogen environment. Okay, the neighbor, on the other hand, you see if this is going to be one hydrogen, the neighbor containing one hydrogen. So splitting is going to be n plus 1. 1 plus 1, 2. You have 2. Here cannot be because you need 4. Most likely you will need 4 peaks. Cannot. Okay, aspirin cannot. Now I roughly 80% sure. Okay, 80% sure that is paracetamol. Let's see some more. Okay, now if you look at 3 hydrogen, look at the one that will give you 3 hydrogen, this one. Okay, and you look at the neighbor. The neighbor don't have any hydrogen, so there shouldn't be any splitting. So check whether you have any splitting or not. No splitting. Okay, good. This is now from 80% become 90% sure. Okay, I have analyzed this. Let's analyze this hydrogen. One hydrogen, one hydrogen. So we are talking about one hydrogen. Maybe we are talking about this hydrogen and this hydrogen. Let's see which one belongs to which. Okay, so the one belongs to OH. Let's see the one belongs to OH. Okay, the one belongs to OH. Okay, you can see that. Look at the data. Okay, the phenol. Okay, see, belongs to OH. 4.5 to 10. Okay, let's look at 4.5 to 10. Which one comes under 4.5 to 10? We are looking into this here. 4.5 to 10. So I can see this one or I can see this one. So maybe not sure lah. Okay, can be both. Okay, can be both. Okay, but let's actually look at the, then we look at this NH. Okay, let's look at NH. Okay. 1 to 5.5. Okay, 1 to 5.5. See whether they have any 1 to 5.5. They don't have here. 1 to 5.5. NH bonded to benzene. Let's see. NH bonded to benzene. For that one, okay, something wrong. Yeah, for NH bonded to benzene, it's not there. Okay, so here, okay, if I can actually see here, it's going to be, I can confirm one of it. Okay, I can confirm one of it belongs to this. Okay, this one I cannot confirm yet. Okay, this one I cannot confirm. Maybe it's wrongly, which I suspect also because you see here, there's a splitting happening. Okay, there shouldn't be any splitting also happening. Okay, and H, there's no hydrogen. Okay, there is carbon here. Carbon, there is no hydrogen here. So there shouldn't be any splitting. I think something wrong here. Yeah, something wrong over there. Okay, but I know for sure it's not aspirin. Okay, so 90% sure. Okay, couldn't make it to 100%. Okay. Okay, this is going to be the reason why I select paracetamol. Yeah, so the answer is going to be paracetamol. You can see here. Yep. Okay, you can see whatever explanation and so on. Okay, they say that it corresponds to OH and NH. Okay, they have one peak between 11 to 12. I think the 11 to 12, they are talking about the NH. Okay, so I mean, they are talking about NH somewhere here. Yeah. So, but I feel that it should be here, the OH. Yeah, but it's okay. Yeah, it's okay. So they mentioned about that, okay? And then they say sketch the NMR spectrum. For the sketching part, okay, for aspirin, you can see they must have 4 different environments for this hydrogen. So you see, if they sketch, okay, I don't want to focus here, okay, but you see, if they sketch, there are 4 different environments, okay, for benzene. And then 1 environment for carboxylic acid, 1 environment for the CH3. Okay, so this one. Okay, 1 environment here, 4 environment here. That makes total of 6 different environments. So 1, 4, 1. So total 6 environments. So you can sketch. Okay, you can sketch. So this is how you identify. Okay, and just to highlight to why OH and NH, they don't split. Okay, similar like what I mentioned just now. OH always appears as a single peak because there is an exchange, rapid exchange with protons in any traces of water or acid. So they will exchange, okay, rather than having splitting, okay, they are going to exchange, therefore there is no splitting. So the hydrogen colored above, the exchange takes place so rapidly until the signal becomes single peak. Yeah, you are not going to get splitting. Also happens in amine and amides, okay, whereby you have the NH. But, okay, if you use heavy water, okay, the OH and NH peak, which is a single peak, will disappear. And this proton, the H in that, they are called as labile proton. Yeah. So now I just want you to think, okay, Sharon, can you give me reason why when you use heavy water, okay, that peak disappear? Do you know what is heavy water? Water that is heavy. Sharon, are you there? Oh, Christopher said something. Okay, it's 5 to 12 CO bonded to NH, 5 to 12. Then correct. So 5 to 12 CO bonded to NH. Yes, okay, CO bonded to NH. Okay, that will be the other one, yeah? So correct. Okay, Sharon, are you there? Let me check. I think Sharon not here. Okay, Sharon is not here. Okay, okay, Ryan, can you tell me, okay, do you know what is the meaning of heavy water?
I'm not so sure, sir.
Again?
Not so sure, sir.
Okay, water is going to be H2O. Yeah, so heavy water, okay, is going to be D2O. Okay, hydrogen, okay, they have hydrogen 1, okay, hydrogen 2, hydrogen 3. They are called protium, deuterium, and tritium. So deuterium, okay, rather than writing it as H, they write it D. Yeah, so it's still water. Okay, so if they say this is heavy water is hydrogen H2O, but the hydrogen is going to be hydrogen 2. Okay, not hydrogen 1. Okay, so water normally it's going to be 2 plus 16, supposed to be 18. Okay, but heavy water is going to be 4 plus 16, it's going to be 20. They are heavier. Okay, that is what heavy water. Okay, but now, okay, Ryan, okay, now you know what is the heavy water. Now, can you explain why if you use heavy water, the peak will disappear? Or maybe someone help. Audrey?
Not sure, sir.
In the beginning, okay, I told you, okay, in order to use NMR, okay, we use hydrogen 1. We use carbon 12 or carbon 13, Audrey?
12.
13. You see again. Let's go back. You see, only atoms with the mass number with odd number hydrogen 1, carbon 13, absorb the energy in the range of the frequency that are analyzed. So you need to use, okay, the atoms, okay, with the mass number, which is going to be odd number. Now, if you use D2O, okay, the mass is going to be hydrogen 2. You are going to use even number, okay? If you use even number, you are not going to see any absorption, yeah? So automatically the peak will disappear, yeah? That is the meaning, okay? So you are not going to, okay, if you use the D2O, automatically, okay, if they are replaced with water, remember they are taking the hydrogen from the water, yeah, the splitting. So when they take the hydrogen from the water for NH and OH, okay, rapid exchange, they are taking the hydrogen, which is going to be even number. Automatically, it will disappear. Yeah, automatically it will disappear. So you are not going to be able to see the splitting, and you are not going to even see the one single peak also there. Okay, so that is going to answer the question, which is going to be, if let's say, if you look back at the figure, the high resolution, okay, shown from a sample containing traces of water. So you see, they're talking about high resolution, yeah? Okay, the high resolution, and then how would the NMR spectrum differ if D2O, heavy water, is being added? Okay, so the difference is, okay, the single peak that appear for NH or the OH, okay, will disappear. Okay, so in this case, we are talking about the one that is going to appear for NH, okay, is going to be either this one or this one, okay. So most likely is the one that just now 5 to 12, yeah. So maybe one of this, okay, one of the single peak will disappear, yeah. So that is going to be happening, yeah. So you see a single peak for OH, okay, will disappear from the NMR spectrum, yeah. The two peaks, okay, look back on the question 6, how would the repeating the NMR analysis, yeah, using the solver will be able to help the pathologist distinguish between aspirin and paracetamol. So you see, for aspirin and paracetamol, this question, how it's going to help me, okay, it means that it will make this, okay, and this one disappear, okay. These two lines, okay, will disappear. So it means that this, if these two lines disappear, it means confirm is paracetamol. Okay, if here, okay, if I use heavy water, nothing will disappear. Okay, this one, okay, nothing will disappear because there is nothing to do with OH, nothing to do with NH. So nothing will disappear over there. Okay, so that is going to help me. You see, two peaks will disappear, okay, from NMR spectrum. Okay, but only one peak will disappear from aspirin's spectrum. Okay, so aspirin, only one. Let's see which one will disappear. Yeah, for aspirin, only this one will disappear. Okay, so for this one, two peaks will disappear. Okay, now, so Christopher wrote something. Let me check. Okay, so using heavy water is to find which peaks are OH and NH. They can help us to predict, okay, like Christopher just now, they say if you use this heavy water to identify, then that is going to be helpful. If from this peak and suddenly from this NMR only one disappear, then I know if only one disappear, then it's going to be for aspirin. If let's say two disappears, then automatically I know it's going to be for paracetamol. So that will actually help, yeah, but that is not compulsory, yeah, because the information itself is enough, okay, it's enough, no need to go and add, but they say if, yeah, they use the term if, okay, that is the difference, okay. Frederick, the 2H above peak represents the number of environment or number of hydrogen in a carbon atom. The answer here, okay, this number, okay, good question. This number, okay, is just going to tell you that the peak represents, okay, the peak represents, okay, one environment. Within that environment, how many hydrogen are there? Yeah. So in this environment, there are 3 hydrogen having this environment. The number on top is just telling you, okay, the number of hydrogen in that environment. So like, for example, if I have CH3, Within this environment, I have 3 hydrogen. Okay, so I write down as 3 hydrogen. So within this environment, you see this environment and this environment is the same. I have 2 hydrogen with the same environment. That's why I need to write it as 2 hydrogen. Is that clear, Frederick?
Okay, sir.
All right. Okay, so here, okay, I have done up to, okay, proton NMR, okay, carbon NMR I will do tomorrow. For those who wants to try some questions, yeah, I have prepared, okay, some the worksheet together with the marking key I have already sent to you. Okay, I will go through those questions tomorrow, also some of it. Okay, but you can, if you want to find out more, you want to revise more, yeah, please go ahead. Yeah, you can actually use that worksheet. But most of the question, I think, if you look at the question, they have amino acid about electrophoresis. And if you look at NMR, okay, if it's either it's going to be 1 year, okay, the paper will be asking about electrophoresis, or they will ask about NMR. Okay, so it is keep on they are changing it. Okay, but you see, the marks that will come from this chapter is roughly about 12 marks. Okay, please take note. Out of 100 marks, okay, you are looking into 12, okay, or 11 marks from spectroscopy alone. Yeah, and this spectroscopy is going to be combined with carbon spectroscopy. And okay, last time they used to combine with mass spectroscopy. Okay, but okay, I told you the mass spectroscopy has been removed. It went to AS. Okay, but we will try some questions related to mass spectroscopy. Okay, because last time it used to be very popular. Yeah, and most of the passing questions involve mass spectroscopy, and then you need to solve. Okay, so I doubt, yeah, that they will completely ignore mass spectroscopy. Yeah, so because it's still in your AS, okay, so you still need to know. So here, maybe after I do the carbon 13, Wednesday or Thursday, yeah, we will do the mass spectroscopy. By Friday, we should be able to finish everything. Yeah, and then after that, we just focus on the revision. Okay, the revision first, we will focus on chemical analysis first. Okay, then after that, we will start to explore the organic and so on. Yeah, so that is the plan. So any question, Donna? Okay, too fast, too slow?
A little bit too fast today.
So here, okay, this one I think some of the students they are absent, so I